Started. Today, welcome to this Pie&AI event, and I will be talking about PyTorch Lightning. The agenda of today's meetup is I will explain the basic components of Lightning, how and why to migrate to PyTorch Lightning from PyTorch, and then I will show you a demo on how to train an image classifier on CFA10 dataset with Lightning. And I will talk about the callbacks and logging provided by Lightning, and then I will also show you a quick demo of Flash Lightning, which has been released recently by PyTorch Lightning team. So let's get started. If someone has any question, then they can raise their hand or ping in the chat. Okay. So let's start with a general model training overview. When you have to train a model, you first load a model, then you prepare your data set, and in preparation of your data set you do some pre-processing, post-processing, do some augmentation, rescaling, etc. And then you create a loss function based on your data set and model. After that you create an optimizer which will be used for gradient descent during backpropagation, and which will optimize your model weights. Then you write your training data set. You will write your training step. In the training step, what you will do, you will take the model and data. You will predict the values from your data, and from the predicted data, predicted values and the original labels, you will calculate loss. Then using this loss, you will use the backpropagation to optimize your model weights. So this is a typical model training flow. So I will show you what are the components of Lightning that come into place when you do code with PyTorch Lightning. So all these model related things will go into a single component or a single class, which is Lightning module. You will define forward function for your model, which will basically take your data and make the inference, run the model through your data. And then you will define configure optimizer function method, which will basically define the optimizer that you are going to use. Then you will define the training step. Training step is basically the loss calculation part from the predicted label and the original label. Then you can use data module provided by PyTorch Lightning, which is basically a class that encapsulates training data loader, val data loader, test data loader, and you can do all the processing inside this data module. But if you want to use a general torch data loader, then you can use that as well. So let's see in the code what are the things essential for creating your model. The first thing is you define a Lightning model, which will you will create a class which will inherit pl.lightning module. PL is basically import PyTorch Lightning as PL. Then you will define the init function. Init function is basically you will define your model inside the init function, and you will create loss function. You can pass here the learning rate and any kind of hyper parameters. After that you define the forward function, and you define configure optimizer. The configure optimizer will basically return the optimizer that you want to use. So here I have returned Adam with model parameter and learning rate. Then you will write the training step, and that's all. You can you can train your model. There is a question: will this recording be available to view at the later time? Yes, it will be available. Let me check if it is being recorded. I think it is being recorded. Yeah. So after you have created your model, lightning model, and you can define you can create trainer object and pass maximum epoch, and there are many arguments available here which you can pass here in this trainer class, like callbacks and logging and quantization and all. And then you just do trainer.fit and pass your model and data module, and it will train. It will start training. Okay, so now I will show you a demo on how to train in image classification with PyTorch Lightning over CFA10 dataset. I will show you both with regular PyTorch, and then we'll shift to PyTorch Lightning. So, okay. So here's the notebook. Uh, First, you install PyTorch Lightning. Uh, then I imported all the modules. Then, yeah. So let me run this. So I load CFAR10 dataset from Torch Vision dataset module, and I load both train data loader and validation data loader. And these are my classes for CFAR10, plain, car, bird, etc. And then I will visualize the data. So here it is horse, ship, bird, and a deer. So the image quality is bad because the original image size is 32 by 32. Then I will create a model. So here I have created a convolutional neural network, a small convolutional model, and I after that I create optimizer and criterion, which is basically loss function. I set the learning rate here, and then I write training step function. The training step function is basically it is taking model and data. So from data I extract input and labels, then I run inference on inputs, which is images of batch size. What is the batch size? uh, 4. So basically this inputs will be 4 images, and this label will be 4 labels, integer labels. Okay, so I predict my labels as ypred and then calculate the loss. So here ypred is my predicted value, and labels is my labels is my original ground truth labels, and then I return the loss. So until here, basically I have defined a model, loaded the data set, which are the first two things to do. Then I define the optimizer and loss function. So I have here defined both criterion and optimizer. Then I will write the training loop. So in training loop, I will iterate over a number of epochs I want to iterate, and then I will uh, do training step, then back propagation, then optimizer dot step. So all these things I have to do by myself. All the training loop I have to write by myself. Then if I want to log the loss and accuracy into a CSV file, then I have to do that by myself using some logic. Or if I have to visualize it with TensorBoard, then I have to do that with by myself only. So we can avoid this. We can easily we can train our model without writing this training loop using PyTorch Lightning. I will show you how. So PyTorch Lightning design philosophy is maximum flexibility, no boilerplate, and self-contained model. So no boilerplate. There is nothing that you have to do. There are plenty of callbacks available that will make your life easy, like TensorBoard weights and bias and CSV logger. Then if you have to do some quantization All these things are available by default in Lightning. And self-contained models like Lightning module has everything required for training your model. So let's import from import PyTorch Lightning as PL. Then I will create the Lightning model. So here I have I have defined init function. In the init function, I have also passed LR, which is learning rate. Then suppose if you want to pass here output input image size, so you can define it here also. And if in later part of somewhere in later part of some method, if you want to use this input size or LR, then all you have to do is save hyper parameters. Then in later part somewhere you can do like this self dot h params, and then you can do input size. So this is how Lightning can make your life simple. Then I have defined this model and initialize the model. Then forward function, which is simple self.model, just pass the data into the model and return whatever output it is giving. Then I write the training step. In training step, I will take batch and batch index. Batch index is basically if your data contains 1000 number of images, then 1000 number of batches, then it will basically 0 1 0 to 999. And so there is a question: do every params sent inside class gets saved in h params? Yeah. So yes, so when you do self.save hyperparameters, so everything you pass in init, all the it gets saved into this save h params object. So you can retrieve it later. For suppose here in the optimizer, I have retrieved the learning rate here uh, using this h params keyword. Okay, so this batch is basically my data batch, which is image and labels. So it is basically list comprehension, inputs and labels are extracted. Then uh, I pass self bracket input. So if if it looks weird, self model, you can do like this also, self dot model inputs. So since it is Lightning module, I can I can do like self inputs also. Basically it will call this forward function. Then I will calculate my loss from the predicted value and the original ground truth labels. And if you want to log the training loss, you can do self.log train loss and log the loss also. I've also defined validation step, which is exactly same as training step, and then configure optimizer, which basically creates the Adam optimizer and returns it. So I have also then created a data module. This data module contains trained data loader and val data loader function. So when I create this, let me tell more about it. So uh, in the above example where I trained in original PyTorch, I defined my trained data loader uh, like this: train loader is equal to torch.utils.data.data loader, and where I pass my train data set, which is a torch data set class object, and which converts it into data loader, which can do automatic batching and processing, enables multi-processing. So this in the data module here, I have defined this train data loader function and val data loader function, which basically returns my data load of respective data loaders. So when I create the object and pass it into the trainer, it will fetch both data loaders and start training it. Okay. One more question. Like in Keras, we have image data generated from flow directory, flow from data frame. Do we have anything of same provision in Lightning in case of custom data sets? Yes, Plavan, in light, I will talk about it in few minutes. So Lightning Flash has a lot of things that can that will help you in writing less amount of code and avoiding all the boilerplates. So here uh, I have defined TensorBoard logger and imported TensorBoard and CSV logger, and both the loggers I have then initialized the lightning model that I created. I pass the learning rate, then I create my trainer and pass the loggers that I defined above. Then I just do trainer.fit light model and cifrdm, which is the cifr10 data model that I created. And uh, as soon as I run this function train.fit, it will start training my model. There's one more question. I believe in PyTorch we have MS folder which has similar functionality like Keras flow from directory. Uh, yeah, Torch Vision has this. Uh, you can load a data set from MS folder. Okay, so let me run this. So what if I tell you you don't have to do these things also? You don't have to create this, write this training step, validation step, define optimizer and all. You don't have to do anything. All you have to do is define which model you want to train on, and just pass the data set and start training. So Lightning Flash, which Lightning team has released recently, do the same thing. So it is a task-based deep learning library which will uh, just focus on the task you are solving and avoid any kind of engineering code. So here it is. Flash is a high-level deep learning framework for fast prototyping, baselining, fine-tuning, solving deep learning problems. It features a set of tasks for you to use for inference and fine-tuning out of the box, and an easy to implement API to customize every step of the process for full flexibility. So basically Flash is based on top of PyTorch Lightning, which allows you fast prototyping, fine-tuning and solving deep learning problems. So suppose if you have to train an object detection model, so you don't have to define create model and all. You just have to do from Flash import, from flash.ms import object detection module, and then you are ready to train your data set. Okay, so yeah, this training. Okay, one more question. Do we train, where do we do a train test split, and in case of ML, train test split? So train test split, you can do by yourself also. Let me quickly see if Flash do it internally itself or not. So like the question you asked, if Flash do Lightning can do this MS classification from folder. So here is the syntax. All you have to do is from flash.ms import ms classification data, then ms classification data dot from folders. You can just specify your training folder, validation folder, test folder. It will load the data automatically. uh, I don't think if it has data frame support as of now. uh, right now I'm not sure about this. I don't think Flash currently has from data frames. Yeah. But you can raise an issue to Lightning Flash GitHub for this feature, I guess. Okay. So loss is decreasing. It was 2 and 0.9. So let me quickly show you Flash intro code demo. So to install Flash, you can do pip install lightning-flash. And since I have already installed it, I won't run that cell. Until here, everything is same. So from here, Flash starts. So you can see here, I have created this data module. Apart from that, to create an MS classifier, all I have to do is from Flash import MS classifier, and I have to specify number of classes and backbone that I want to use. Backbone here can be any type of any type of model, I mean any type of standard convolutional architecture. So here you can see what are the available backbones. ResNet 18, ResNet 3450, VGG, DenseNet, and so it also has TIM support, which PyTorch image models, which has more than 130 models, which you can just pass it as a string here. So I have here pass backbone is equal to ResNet 18 and model is equal to MS classifier, and it is the model has been created in just one line, and all I have to do is flash.trainer and specify the maximum number of epochs and just pass my model and data model, and it will start training. This configuration. Okay, I am running on my laptop, so I don't have GPU. Yeah. So you can see here validation accuracy, loss, and training accuracy. Everything is I didn't write any training step, validation step, or anything, but it is still calculating everything for me. So that's apart from image classification, Lightning can do a lot of things like uh, it has text summarization task in this. So lightning from flash.text, you can import summarization task and just use this. So and after lightning, after flash summarization, there is text classification, then which you can simply flash.text import text classifier and just model.predict. You can pass your text and it will make the create the prediction. That's it. And apart from the text, it also has object detection support. So you can easily fine tune any you can easily fine tune your RetinaNet or any deep learning model. So I think they already there are 2-3 models integrated in Flash, and more models are yet to means will be integrated soon in this Flash, and you will be able to train any kind of object detection backbone model. So So you can follow Flash documentation. It is available at lightning-flash.readerdocs.io. You can also go to the GitHub repo and check the code, and uh, you can also contribute to some of the issues of Lightning. Yeah. So that's it from my side. Does anyone have a question? I see chats. Uh, how do we do fine tuning? So fine tuning, are you asking for Flash or is it for just Lightning? So, okay. So for Lightning, if you want to fine tune, like if you want to freeze your backbone and just train your head of the classifier, then you can do it in Lightning. You can freeze the uh, freeze the backbone of your model. You can, but I would recommend you can use Flash easily. So in Flash, what it offers is you can just pass different kind of fine tuning method. uh, Let me show you. Yes. So it has different kind of fine tuning methods. So it is already inbuilt. All you have to do is just pass inside your trainer and it will handle everything for you. You don't have to freeze or unfreeze head model and then backbone and all. So it has fine tuning, then backbone, then freeze, then unfreeze. These are the terms. I think there are some examples here also. So trainer dot fine tune, and in the strategy you can pass uh, the terms defined here. So in this the strategy is freeze and no freeze. So there are a lot of fine tuning strategy that are mentioned here. So you can uh, read upon here and you can choose the best that suits to your problem. Okay, freezes only the base layers or head as well. Well, this. Okay, yes, this is being recorded and it will be available later, Anirudh. So freezes the base layers or the head as well. Uh, if if you are if you are using Flash, so here you can read what does freezes. So it depends upon your use case. If you want to freeze your backbone or train both backbone and head, so let me see the example. So if you do freeze here, then backbone will be frozen and then you can train your head. So here you have defined image classifier with backbone as resonate 18. So let me show you with code. Uh, So when I created a model here with Resonate 18 as backbone, you can see this model has a attribute named backbone, and it is basically my Resonate 18 backbone model. And there is no linear layer, fully connected layer in the last. And if I do head here, it is just a linear layer with out features 10, which is my number of classes. So when you freeze the backbone, your uh, backbone will not train during backpropagation, only your head will train. So that's how you can freeze and just fine tune the last layer. Uh, okay. You can see the TensorBoard callback that I used. So training loss is logged here, and epochs are also logged here. So I didn't have to do anything, just call the TensorBoard class and pass it inside the trainer, and it took care of everything by itself. Validation loss is also logged here. So yeah, you should use Lightning to make your life simple, to remove the training loop and scale your models, and it provides a lot of things. You can check at the documentation of PyTorch Lightning. Uh, do we have any more question? Okay. Okay. Uh, so thank you for joining everyone, and this video will be uploaded to YouTube, and you can subscribe to my channel. And this also this code is already there on GitHub, so it is on my GitHub account. Uh, Here it is. You can go to aniket/talks, and inside PyTorch 2021 627 PyTorch Lightning, all the notebooks and slide, everything is present here. So you can just go here and run the notebook. You can try out the code with your own data set, or uh, any kind of custom data set. You can try both the notebooks. Okay. So okay. We don't have any more question, then we can end this meetup. Thank you all for joining.